Good morning, everybody. Welcome to the fourth webinar in our Learn with Scholars Portal webinar series. So if you've attended one of these previous webinars, the goal of this series is to give a chance for Scholars Portal staff to be able to share out with the rest of OCUL some of the more specialized knowledge and skills that we've developed at Scholars Portal. So today we have our senior metadata librarian, Wei Zhao, who will be talking about linked data. I just have a few housekeeping things before we get started. First of all, I wanted to acknowledge the land that Scholars Portal operates on, which for thousands of years has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. And today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we're grateful to have the opportunity to work and to live on this land. I know that we have people joining us from across the province and maybe even beyond today, so feel free to add your own land acknowledgement into the chat if you would like to at this time. This webinar is going to be recorded today, and the recording will be shared fairly broadly afterwards. We have about a 40-minute presentation. After the presentation, we'll stop the recording and we'll have a lengthy time for a question and answer period, and it won't be recorded, as I said, so feel free to ask any question that you want at that time. During the presentation, we ask that you please keep your microphone muted and your video off. If you do turn on your microphone or video at a time when you shouldn't, then myself or my colleague Amy may forcibly turn it off for you. We do have some of the slides today. I'll just put those in the chat. So if you wanted to follow along with our slides this morning, then you can do that using the link that I just put into the chat. And I will turn on the closed captions before we get any further. Okay, great. So the closed captions are now on, so you can turn those on if you would like. And now I'll turn it over to my colleague Wei, who will be presenting this morning.
Okay, thank you, Sabina. Sorry, it seems like I have problem to turn to the next slide, so I'm going to stop sharing and then share that again to see if it worked. Okay, great. So a little bit about myself. Welcome everybody. My name is Wei Zhao. I'm the senior metadata librarian at Scholars Portal. Some of you may know me because I have been with Scholars Portal for a long time. It's more than 10 years now. So my major role at Scholars Portal is supporting our eJournals platform, which contains more than 60 million articles now. Several years ago, Scholars Portal purchased MarkLogic Semantics license. So we started several linked data projects using our journals data. So we learned about linked data while we do it. Linked data is a big topic. So today I won't be able to cover many details, but hopefully you can take away with a better understanding of the core concept and the principles of linked data and why linked data benefits your library. So you may consider start your own linked data project or participate in a linked data project. Okay, so today I'm going to cover linked data principles, linked data technologies, the expected benefits of linked data, an overview of linked data projects, and finally talk about Scholars Portal linked data projects. Okay, so what's linked data? Linked data is a set of design principles for sharing machine-readable interlinked data on the web. So Dr. Tim Berners-Lee brought up these linked data design principles. First, use URIs as name for things. Second one, use HTTP URIs so that people can look up those names. Third, when someone look up a URI, provide useful information using the standards such as RDIF SPARQL query. The last one, include links to other URIs so that people can discover more things. So RDIF, Ontology, and the SPARQL are the core foundation of linked data technologies. RDIF for describing the linked data, Ontology for defining linked data, and finally SPARQL query for query the linked data. So today I'm going to cover these three core technologies. RDIF, Resource Description Framework, is a framework for describing resources. The resources can be anything. So the RDIF is designed to be read and processed by computers. RDIF makes statements about resources. A statement always has the structure of subject, predicate, and the object. So we also call that. Okay, so RDIF use IRI or URI to identify a resource. RDIF graph consists of multiple triples. So these definitions can be joined. So let's take a look at an example. Okay. Some problem with my screen sharing today. Okay, so let's take a look at this example. So we want to make a statement. William Shakespeare is the author of Hamlet. So we present this statement in RDIF triple. So first, the subject is Shakespeare. So we use a wealth entity, the authority file for Shakespeare for the subject. And then predicate, we use schema.org, the author, to define the relationship that's defined as the author relationship to the object. And then finally, the object is Hamlet. The URI comes from the WorldCat URI. So in RDIF triple, for the machine to be able to process the data, so all the subject, predicate, and the object should use URI. Okay, as I mentioned before, multiple triples consist of a graph. So in this example, in one triple, it makes statement that Bob is interested in Mona Lisa. So in this triple, Bob is the subject, is interested in is the predicate, and the Mona Lisa is the object. But for another triple, the Mona Lisa is the subject. So Mona Lisa was created by Leonardo da Vinci. So in this triple, the Mona Lisa becomes the subject, and was created by is the relationship between Mona Lisa and its object, Leonardo da Vinci. So from this graph, we can also make a conclusion that Bob is interested in Leonardo da Vinci. Even this statement is not expressed explicitly in the triples, but based on the data we have, based on this linked data model, we can make the conclusion. So this is called inference. So the fact one resource, for example, Mona Lisa, can be the object of one tuple. At the same time, it can also be the subject of another tuple is very powerful. So it makes it possible for us to find the connections between the resources, and the tuples can expand on and on to form the knowledge graph. Okay, so comes about the ontology. So the ontology is a way to express semantics of concepts in a formal way. It defines the concept. We also call that class or type in ontology. And relationship, we also call that property. That's define the relationship. Ontology describes specific types of things or things in a given domain or industry. The web ontology language is a language for authoring ontologies. Ontologies allow us to add meaning and the relationship information in triple statement in a standard formats, so that computers can process the meaningful relationships and serve meaningful search results to humans. So ontologies are the basic building blocks for inference techniques on the semantic web. Okay, so here are some commonly used ontologies I'm going to introduce so you can know better about the ontology. So first one is schema.org. Schema.org is a common ontology to describe anything on the web. It has over 10 million sites use schema.org to mark up their web pages. Many applications and the search engines use it too, including Google, Yahoo. One of the Google search engine optimization technique is adding schema.org markup to web pages, so Google can understand the semantic meaning of your data for better search result. So our Scholars Portal digital content also is modeled based on this schema.org. So here is an example of an entity of schema.org ontology. So this is for the book. So you can see the book in schema.org, it defined as a schema.org type. So that means it's a concept or it's a class. And above book, it has its parent type, created work. And the parent type for created work is thing. So actually the thing includes everything. So all the child types is under the one big thing. So under that, you can find the URI for this entity about book. So in this URI, as Tim Berners-Lee described in his linked data design principles, if you go to this URI, you should be able to more information about this entity. So in this URI, you can find the book is a type, and then you can find the list of the properties for that book. So that means you can use that properties to make link to other resources. So for example, a book can have an illustrator. The illustrator can be a person, okay? And then a book can have ISBN. And then because the book is the child type of creative book, so it can also inherit the properties of creative work. So you can see under created work, you can have the abstract of that work or the author of that work. Okay, so that's schema.org. This one is Vapoframe, is bibliographic framework. So this framework is developed by Library of Congress. It's a data model for bibliographic description. Vapoframe is designed to replace the current MARC standard and to use linked data principles to make bibliographic data more useful both within and outside the library community. So like other anthologies, it consists of classes and the properties. So the screenshot you're seeing is from the Vapoframe model version 2. So you can see there are 3 core classes. It's work, instance, and the item. So for example, the work can be like Romeo and Juliet. And for this work, it can have a subject. And then under the subclass of the work, we can have the instance. So the instance, for example, we can have a book of Romeo and Juliet. So the book, Romeo and Juliet, can have a publisher. And then finally, it can have item. So we have a copy of this book held by Library of Toronto, the University of Toronto Library. And this item can have a barcode. Library of Congress also developed a series of tools for Vapoframe implementation, including MARC 21 record to Vapoframe conversion tool and the Vapoframe editor. So the catalogers at your libraries may already got training about this framework. Okay, the next anthology widely used by library, especially by catalogers, are the WIF. So the WIF combines multiple name authority files into a single OCLC hosted name authority service. WIF contributors are mainly from the national libraries of different countries. So they regularly supply authority data that WIF matches links and the groups. So all the descriptions for a given entity are merged into a cluster that brings together the different names for that entity. So this service allows researchers to identify name, locations, works, and expressions while also preserving the regional preference for language, spelling, or the script. So for this example, that's the one WIF entity for William Shakespeare. So that's the one I used in my first triple example. So you can see for this name authority file, you can find English version, and you can, from the same entity, it can be linked to all the name authority file in different languages. Okay, finally, the SPARQL query. So SPARQL is a query language and a protocol for accessing RDIF. It's similar to XQuery for your XML data. So SPARQL query can help deliver service internally, and it can also help of outside endpoint. So here is SPARQL query at Scholars Portal to query our book review triples. Basically, this query say, give me all the books URI that have the review of relationship in the triple store. Okay, so we have learned about the core technologies of linked data. So the RDIF, the anthologies, and the SPARQL query. So why we use the linked data, the power of the linked data? So first, it can make local resources discoverable on the web. So for example, Hamilton Public Library published their bibliographic data as linked data. So the Google users can find their way to the local library. So this is the inside-out concept. The resources which unique to an institution can be reached by non-institutional audience. The second one, so linked data help provide related web resources to local users. For example, Scholars Portal's platform, the eJournals platform, provide link to OCAD ID site for more information for that author. So this is the outside-in concept to bring external web resources to local users. And finally, the linked data can help create knowledge out of interlinked data. So the whole idea of linked data technology is about connecting semantically related data that wasn't previously linked so that the data can be exchanged, reused, and integrated in machine-readable form, whether the data is on the web or within your organization. Okay, so here I'm going to introduce some well-known linked data projects. So the first one is DBpedia. Okay, so DBpedia extracts different kinds of structured information from Wikipedia and make the information available on the web. DBpedia knowledge base contains billions of triples about persons, places, created works, music albums, files, video games, organizations, all the things you can find on Wikipedia. So DBpedia is the main resource of linked open data on the web. It is the most interconnected, freely available knowledge graph on the web. So for DBpedia, the dataset can be downloaded and their endpoint currently handles 7.2 million queries every day. So DBpedia allows you to ask quite surprising questions. So here is an example. From the DBpedia endpoint, you can try your X query. For example, this SPARQL query is basically query the DBpedia linked data set. That means gave me the list of people who were born in Berlin before 1900. So you can use this DBpedia SPARQL query endpoint to try your own SPARQL query to see what answers you can get from DBpedia. Okay, another project I want to introduce is Google Knowledge Graph. So Google retrieves structured information from many sources, including the CIA World Factbook, Wiki Data, and the Wikipedia. The knowledge graph contains over 70 billion facts. So those facts and the links are organized based on schema.org we mentioned before. With the knowledge graph, Google can better understand your query, so it can summarize relevant content around that topic, including key facts that you are likely need for that particular thing. So the information from the knowledge graph is presented as they called knowledge panel to the right side of the search result. So here is an example of the Google knowledge graph about Charles Dickens. So when you search Charles Dickens, this knowledge panel appear on the right upper side of your search result. So it provides relevant fact about Charles Dickens. For example, his birth date, death date, his spouse, children, and his movies and the related people. Okay, so the last well-known linked data project I want to introduce is Wiki Data. So the Wiki Data acts as a central storage for the structured data. So Wiki Data is used by institutions both to retrieve data from Wiki Data and to update and upload the data to the platform. So some of the libraries use Wiki Data as a platform for publishing, linking, and enriching library linked data. So similar to DBpedia, Wiki Data is also a structured database. It's also free and it's multilingual. So the Wiki Data content is in linked open data ecosystem. So Wiki Data creates bridges across different domains. It impacts search engine result, and it is an identifier hub. So I attend NISO Plus conference last month. There is a presentation from London School of Economics Library. They present a project that demonstrates how Wiki Data can be used as a tool to push out data beyond organizational silos. So the LSE library upload their historical thesis collection to Wiki Data. So the analysis of 80 titles added to Wiki Data. So the downloads in the 6 months after adding the titles to Wiki Data is on average 47% higher than the 6 months before they are added to Wiki Data. So that's a dramatically increase. So this project improves the discoverability of library resources on the web. It demonstrates the inside-out concept of making local resources accessible by broader communities. Okay, so linked data technology is also widely adopted by library community. So I want to mention the following library linked data projects. So for OCLC, we all know OCLC published the Virtual International Authority file that's WILF as linked data as an anthology. And recently, OCLC is working on the project of building shared entity management infrastructure. So it's focused on accessible authoritative description of entity of works and the persons. Another project I want to introduce is LD4P. So that's linked data for production. So LD4P is a project funded by Mellon Foundation to build linked data tools for library resources. Linked data for production partners include Columbia, Cornell, Harvard, Library of Congress, Princeton, and the Stanford University. the project has a number of outputs. The major one is Snowpeer. Snowpeer is a free web-based tool for creating RDIF data using any anthology. So the library can create metadata in linked data environment without having to set up and maintain their own tools. So I put the link there, here on the slide, so you can go to their website and to try this tool and also provide feedback. And the next, the ALMA. So OCUL schools, most of OCUL schools adopt ALMA as their knowledge base. So ALMA enrich the MARC record with URIs using a number of anthologies such as WELF, FAST, and convert MARC record into linked data based on Vapoframe. So the linked data is available in ALMA UI and APIs. So the last one is links. The links project is a linked data project for Canadian culture research. The links infrastructure project will convert large data sets into an organized, interconnected, machine-processable set of resources for Canadian culture research. A number of Scholars Portal staff participated in this project to provide technical support. Okay, so here come to Scholars Portal linked data project. So Scholars Portal staff has been working on modeling Scholars Portal metadata as linked data. So the linked data model is based on schema.org. So parts of the metadata already converted to linked data. So for now, we focus on the classes for article, book, organization, and the person. So right now, the book and the book review articles already got linked to each other. And we use GRID, the database for organization ID to disambiguate organization. And we also OCAD ID, personal ID, to disambiguate the author name. So you all know Scholars Portal hosts digital content. We have separate platforms for journals, books, GeoPortal, Dataverse, and Odyssey. So the metadata are all stored in MarcLogic. However, they remain in separate siloed databases using different metadata standards and formats without link to each other. So the linked data model makes it possible to build linkages across Scholars Portal collections for enhanced discovery. A script has been developed to extract the entities and their relationship from the Scholars Portal digital collections, such as books and the book review article, a journal article, and its referenced dataset. The triples are stored in MarcLogic triple store alongside of document store. The subject or object of a triple can be a document in Scholars Portal digital content database. Therefore, the document in Scholars Portal digital collections are semantically enriched and linked. So right now, about 1,700 book review articles on the Scholars Portal Journals platform are linked directly to the titles being reviewed on our Scholars Portal Books platform. So right now, we're working on building other link engines based on our linked data model. Okay, so GRID database is implemented to disambiguate organization name when we focus on organization class in our linked data model. So GRADE is Global Research and Identifier Database. It's an open access database of educational and research organizations worldwide. Each unique GRADE record contains relevant metadata about that organization, such as institution's type, official website, geo-coordinates, and the Wikipedia page. The recent release of a GRADE database contains more than 100,000 institutions. So some of the publishers start to include GRADE ID or Ringgold ID for authors affiliated organization in the data they send to us. But in most cases, the affiliation information is included in the AFF tag as free text. So right now we have downloaded GRADE ID database in our MarkLogic, and we have created an entity dictionary in MarkLogic. And using the MarkLogic tool, we have extracted the entities of country name, city name, and the GRADE ID label from the free text of AFF tag from the article XML. So here is an example. So you can see in this AFF tag, all the affiliation information is presented as a free text. So using the entity extract tool in MarkLogic, we extract the entity for country name ID, and the name is Japan, and the GRADE ID label. We got the GRADE ID label for National Institute of Technology, and we also got the city name is Suzuka. Okay, so same as similar to GRADE ID for organization. So OCAD ID is the ID for person. So OCAD ID is the persistent identifier for a person. OCAD ID record provide lots of information about the person, such as the education, the employment history, and the work list. So OCAD ID is releasing the public data file under CC0 every year. So we are in the process of download the most recent OCAD ID public data file in MarkLogic. So right now, a user interface has been developed to explore OCAD ID record. The data can be browsed by region, by city, and by organization name and organization tag. So here is an example. So for this article, based on the work, we extracted the affiliation information and identify the author of this article is from Canada. So we highlight this article using this icon focus on Canadian scholarship and bring a link so the user can browse the Canadian scholars by this interface. So they can browse by the organization name and to see other Canadian scholars in that institution. So these features is still in test now. So, but after we download the most recent OCAD ID public data file, and we make like a little bit twist of this interface. So we hope we can release this feature soon. Okay, so here is the Scholars Portal metadata linked data model. So you can see right now we focus on the 4 major classes, that's book, article, person, and the organization. So for the relationships, so we can see an article can review a book, and the article can have an identifier, a DOI. So in the meantime, the article can have an author. The author is a person. So we disambiguate this person using OCAD ID. And the article can also have a founder. The founder is an organization, and we disambiguate the organization name using the grade ID. And also the author of that article can affiliate it with an organization. And at the same time, we also disambiguate the organization using this grade ID. So the grade for organization and the OCAD ID for the person also can link to geonames. So we can get the more geolocation information about that organization or about that person. Okay, so modeling Scholars Portal digital content metadata as linked data based on schema.org and the persistent IDs, as I mentioned, grade ID or OCAD ID. These provide great potential to improve the discoverability of our content and so much more. So we will continue work on adding more linkages across Scholars Portal content. In addition to that, we will be working on developing a standalone application for studying analytics of Canadian scholarly research. Since we have disambiguated the author's affiliated institution using grade already, and that grade ID connected to GeoBase for geolocation data. So we are able to pull all the information about Canadian scholars. So we could answer the questions such as which schools in Canada have the scholars producing articles in the field of intellectual property, or which fields of study have high level of co-authorship. We will be also working on developing journal entitlement management tool based on linked data model. So we have already created the basic model based on linked data and test some of the Sparkle queries. So the new entitlement manage tool for journals will help us manage entitlements better, and it will also help us to track information that are not able to track in our current XML model. So the CRK and knowledge-based entitlement subcommittee that I also sit in is currently working on the perpetual access tracking project intended to collect and record the perpetual access entitlements of CRKN members for licensed journal content. So we plan to integrate this perpetual access information from CRKN into our OCUL entitlement management tool. Okay, so the linked data technology allows libraries move from a record-based approach towards a more granular, flexible systems that rely on entities and relationships. So I think it will improve what libraries are able to accomplish in a dynamic web-based information environment. Okay, so that's the end of my presentation. so we can discuss if you have any questions and ideas and then like linked data project you are interested.
Thank you, Wei. This is really fascinating and I'm really excited. I am going to stop the recording now and then we'll have a Q&A session. I see there's some applause and some thumbs up coming in from the attendee pod. All right.